So, hello guys, welcome to our Backbencher Studies channel. So, in this video, we are going to discuss the block diagram reduction rules. In the last class, we have shifted these takeoff points and summing points, and based on that, we achieved something which will be very useful. And if we shift this, we will be multiplying or dividing the gains as per our shifting, whether it is left shifting or right shifting, or whether it will be a summing point or a takeoff point. Based on that, we will be multiplying this. Uh, we will be multiplying this gain of this block over which we have shifted. So moving on to this next rules, we have rule 8 of interchanging summing points. This is basically a property of this associativity we have already seen in mathematics, which is nothing but if we take three variables a plus b plus c, and first if we add a plus b, and if we add c to this a plus b, which will be same as a plus c plus b, same like that. Same associativity property over here we have applied based on this interchanging of summing points. We have first summing point A over here and second summing point B over here, and the two signals which will be coming into this summing point are R1 and R2, which are the inputs, and we have this output of the summing point as R1 minus R2, which will be the input to this second summing point, and the second input to this P summing point is the R3. So thereby giving us this output R1 minus R2 minus R3 over here. So this is how we obtain an output from this. So if we interchange these two summing points over here, and that is placing this B summing point in front and placing this A summing point, and at these positions, if we interchange these positions, we have the same output, that is R1 minus R3 coming into this first input of A, and R2 being subtracted over here, thereby giving us same output. So we cannot, so we can interchange these summing points without doing any manipulation in this network. So this is how a rule 8 will go on, and we have these two important rules: shifting of takeoff points after or before summing point. So we have this takeoff point before summing point, so we need to shift this takeoff point after this sum before. So we need to shift this summing point uh, before this takeoff point. How do we do that? So let us see. If we are let x1 be this input, and the takeoff point will have the same input which will at this point. So x1 will be the takeoff points, and the second input be x2, thereby giving us the x1 minus x2 as this output. So we if we shift this summing point to this left side before to this takeoff point, we can have something like this. So the x2, thus this summing point over here is shifted to here. So this is the summing point and this is the x2. So then this output of this summing point, so this is the takeoff point which is being shifted, which is there at that place. We need to then the takeoff point will have what is called x1 minus x2 as the signal. So we need to eliminate this x2, which will be subtracted from this x1. So for this elimination, for this compensation of this shifting, we add the x1 over here, so thereby giving us two summing points. So if we interchange, we need to interchange this shifting and summing points, interchange their positions. We need two summing points over there. So this takeoff point will have another summing point, thereby giving us same signal as before, so as to compensate this shifting. So shifting of takeoff point after summing point. So we have summing point over here, so we need to shift this, we need to interchange this both of these positions. So how will we do that? So we have this input as x1 and x2 as this second input, and we have x1 minus x2, which is the output, as well as this output of this takeoff point. So if we shift this summing point over here, we have this x1 only in this takeoff point, because this takeoff point is moved to this position. We have x1 only. So what we need is x1 minus x2. So we need to add another summing point after this takeoff point. After this takeoff point, we need to add another summing point, so as to compensate, so as to make the same output after this summing point. So this is the added summing point, and this is the summing point which was already there in previous, thereby making this same output x1 minus x2 over here, and making same output after this summing points x1 minus x2. So the basic funda here is, the basic thing here is to not to change this output if we are manipulating something, and not to change this output of this takeoff point. After manipulating also, we need to make sure that it will be, the signal will be same before and after. And if we have done that, then we are in a good way to actually solving the problems. So these are some important rules. So in the next class, we will be solving some of the simplified problems, and thereby we will be moving on to the tough problems. So block diagram reduction is a very important concept. So next we will be solving problems. Thank you guys, and if you are new to our channel, please to subscribe to our channel. And if you like this video, please do like, and if you have learned something, please do comment this video. Thank you guys. Thank you for this session.